In linear versus exponential, function A, we have $500 deposited into a bank account that earns 5% simple interest. The balance in the account is a function of the number of years since the $500 was deposited. So in the table on the left side, we're using function A, and in 0 years, there will be a balance of 500. For your process, you can simply type 500 here because you're not really doing anything the first year. Now after that, you're going to add an additional amount of money. To find that money, if it's simple interest, you will multiply the initial deposit, which is $500, times 5%, which is 0.05, and then for 1 year, so you can do times 1, that's going to give you exactly $25. So in year 1, you would put 500 plus 25. So your total balance would be 525. Now in the next row, instead of changing this or adding these numbers, leave the 500. You are going to add 25 again. Since this is simple interest, you add the exact same amount every year. So instead of saying 50, let's add 25 twice. And then our total is going to go up another $25, so that would be $550. And then for the third year, this is $500 plus 25 3 times. And so it's $575. And then fourth year, 500 plus 25 times 4. So that's an even $600. And I should probably put my dollar signs on here. So, all right, so what we need to do is fill out the last row of the table following the same pattern. So you'll know that every row in the table does have a 500, so we're going to put 500. We're adding 25. And then unlike sequences, you may notice that the numbers in the left column match these numbers in the parentheses. Like this is a 4, and so is the 4 here. This is 3 and 3 and 2 and 2 and so on. You could put a 1 here. You could even do plus 25 times 0 there. So that means that for X years, you're going to multiply 25 times X, or just type 25X to get your expression. Now, there's a huge difference between simple interest and compound interest. So function B, we are not going to use that same strategy. Instead, we're going to take the $500, take 4% of $500, and then add that back. You may happen to know that 4% is 0.04, multiplied by $500 is $20. So we'll go with $500 the first for the first balance, and then we'll do $520. And then with compounding yearly, you take the balance at the end of the year and you calculate interest on the new balance. So you would multiply 520 times 0.04, and then you would add that total back, and you will get 540.80. So what I need to do is figure out what I'm really multiplying by. So if you'll take and divide 520 by 500, you will see that you're actually multiplying by 1.04. And then if you take that and multiply again, you'll get 500 times 1.04 raised to the second power, because you're going to multiply by it twice. And then I'm just going to put that in the next row and change this to a third power and a fourth power. So in the last row of this table, you would have $500 times 1.04 raised to the x power. Okay, let me fix that. All right, so Next, you're to match one of these functions with one of the graphs here below, and they just happen to match up the same order they're in. So on the left side, we have a linear function because it's increasing at a constant rate, $25 each year. So the graph on the left actually represents that. So you could label this graph A of X, and then the one on the right is the one that's B of X, and this is the one that's in, this is an exponential function because you're multiplying by a number, sort of like a geometric sequence. Now you'll notice these are not exactly like geometric sequences for a couple of reasons. First of all, the term numbers are always 1, 2, 3, 4. They do not include 0, so we have zeros in these tables. And also these graphs are continuous. For a sequence, we would not connect the dots on the graph. To answer these questions here, you would write an ordered pair as a function. So you would say for the first one, A of 30 is equal to 1,250, and that means after 30 years the balance is $1,250. And then you could say something the same, similar to that for this one. You would say A of 27 or B of 27 is $1,441.68. That's after 27 years. The balance in the account would be $1,441.68. To label the y-intercept on each graph, both of these graphs have the same y-intercept because they both start at 0, 500. So this point here and this point here you would label with 500. And what does it mean? It means you started with $500 in the account. To classify each function, the first one would be classified as a linear function because it's a straight line. It's decreasing at a constant rate. And the second function would be classified exponential. And if you're not sure how to spell those, the spelling is up here at the top of your assignment in the title. So you can use that to help you spell exponential. To write an equation for the function in function notation, you almost have it here. On the bottom row, it says 500 plus 25x. So you could say A of x equals, and then you would put the rest of that. So 500 plus 25x. But just be sure when you're typing an equation for each function that you do have an equal sign, because that's what makes it an equation. For number 8, to use the equations to find these values, you replace your x with 20 and then you simplify it to see what you get. When you're doing the one for exponential, in fact I'll do that one now to show you, you would put a 20 for your exponent, and so your calculator is going to give you a whole bunch of digits, sort of like the one in the graph, but you don't need to write all the digits. You only need to write enough like to the nearest penny. So you can go 2 places past your decimal and then round your answer off. So if you take $500 and multiply by 1.04 20 times, so that's raised to the 20th power, you should get $1,095.56. So that would look like this. B of x, or B of 20, equals $1,095.56. And then what does it mean in context? I'll move this one over here because this is on the right. Well, it means this. In 20 years, the balance will be $1,095.56. Okay. When you were doing your edge elastic mixed practice, there were several like that, so you may want to really pay attention to question 8, because on question 8 you've got 2 numbers here, the 20 in the parentheses and then the number on the right, so your statement should include the 2 numbers in context, so years and balance. On the next page you're just basically doing the same thing again. This time we have $700 deposited into an account earning interest. You do need to put y equals, b equals, a of x equals, something equals. So I'm going to say y equals, and then I'm going to start with $700. And since this is simple interest, I'm going to add a certain amount each year. Well, it's 3% simple interest, so you would simply multiply the $700 by 0.03 to see how much simple interest you're going to earn, and it's exactly $21. So it would be 700 plus 21x for your equation. Be sure you have the y equals in the front, or you could put f of x equals if you want function notation. To classify the function, you would say linear because this is a straight line. And what is the balance after 10 years? Take the x and replace it with 10, and you'll get 700 plus 210, which is $910. And then finally, what is the y-intercept of the graph? Well, that's actually 700 because it started with a $700 deposit. When you do question number 10, you'll notice that it starts with $950 and the interest rate is 4%. Well, that is the exact same interest rate that we had on the first page. So it's going to look a lot like this problem, but the main thing you have to pay attention to is the 500 is no longer 500. It's going to change to 950. So I could say B for balance equals $950 times 1.04, and that would be raised to the x power. So that would be my equation. Notice it's an exponential function, so you would say exponential for part A. The balance after 10 years, you would take your exponent and you would replace that with a 10. So let's see what that is. We would have to round this one off to the nearest penny. So to the nearest penny, this would be $1,406.23. What is the y-intercept of the graph? That would be 950, and that would be the number of dollars you started with, or the deposit. Now, the tough part on 11 is you do have to label what all this means. The B stands for balance, and the X stands for years. And most students know that the 1,200 is the initial amount, or it's the beginning balance. But what most students don't know is that this number 1.02 is not your interest. What it actually is 102%. And that can be broken down into 100% of your current balance plus 2% interest. So in this particular equation, what you're doing is the balance in the account is increasing 2% per year. So don't just say interest. You need to say this number, 1.02, means 102%, which is 100% of the current balance plus 2% interest. Part B is this compounded yearly or simple interest. Well, you'll notice it's multiplying by 1.02, so that would be compounded yearly, and that's how you tell. It's an exponential function. It is multiplying by some number. On number 12, we start with 350. Well, that would be like your initial balance. And the 21 is your simple interest. You're adding the same number each year. So the answer to B was, is the interest compounded yearly or simple? It is simple interest because it's a linear function and it's adding exactly 25 per year. Hopefully that helped you fill out your notes. If you have additional questions, I do have tutoring on Wednesday. So I will see you then. Have a great day.